Okay, so what mathematical patterns in tables, graphs, and rules are typical of exponential decay? Alright, when doctors prescribe medicine, they must consider how much of the drug's effectiveness will decrease as time passes. For example, each hour a certain drug is only 95% as effective as the previous hour. Okay, so, like, for example, if you take, like a Tylenol or whatever, you got to take it again like every 4 hours or whatever the case may be, because your body metabolizes it. You use it up. You use the medicine up, right? So the amount of it goes down. Okay. Now, in exponential decay, we're not necessarily concerned with what was lost. One more.
Yeah, one out there.
Yeah, we're not necessarily concerned with what was lost. We're more concerned with what remains. Does that make sense? Like yesterday with the pennies. We took the heads, we got rid of them, we didn't even count them. We only counted the ones that stayed. Does that make sense? We didn't count how many we got rid of, we count how many stayed. So that's decay, you're interested in what stays. Okay? So what is the decay rate for this situation? Okay? This is so it's a 5% decay. Okay? We keep 95%. So the decay part is a 5% decay. We keep the 95%. Okay? Consider starting with 250 milligrams. 250 milligram dose. Write an equation that would model the amount of medicine remaining after X hours. Okay? The 250 represents our A value, our starting value. Okay? The 95% is our B value. Okay? So we end up with Y equals 250 0.95 raised to the X power. Where did the 0.95 come from? 95%. I take 95 divided by 100, 0.95. I know immediately by looking at my B value, I know immediately that this is what? It's decay. Okay? I see a 0 on the front. See a 0 on the front? Decay. Okay? Also, if you see a fraction that's less than 1, that would be a decay. So just if B equals 4 over 5, that's just a sidebar example, that will also be decay. Okay? Some number less than 1, but still positive. Okay? So how much money will remain after 6 hours? Let me edit this real quick.
Can you give me the calculator?
So looking at this equation, okay, what does 250 represent? 250 represents milligram base? Start. This is the start, right? 0.95 represents 0.95 is the, before we were calling it a growth rate before. Now we're going to call it a what? It was a growth rate. Now it's a decay rate. Okay, this is a decay rate. X represents what in this situation? X is always stages. What are our specific stages in this scenario? These are hours, right? Not years. No, these are hours. Okay? Y in this situation represents Y represents what does Y represent?
Feedback.
What does Y represent? Anybody? What does Y represent? Okay, that's the amount remaining, right? Okay, that's the amount remaining. Okay. Number 3. So the question says, how much medicine will remain in your body after 6 hours? Or whoever took this medicine's body after 6 hours. Okay, 6 hours is an example of what? This is a what? Okay, that means x equals 6. To translate that into mathematical terms.
So that means that you rewrite the problem
My man.
and you raise it to the x power.
To what power?
The 6.
To the 6th power, right? So in this case, we're going to replace the x with 6. Okay? This goes right in the calculator. Now, when you do this in a calculator, so I can still imagine it still confuses some people. You only actually type this part of it in the calculator. You don't type the y equals. Okay? So you just type that side of it in the calculator. And you just type 250 0.95 caret 6. That's how it would look in the calculator. And when you do type that in, you get what? Wait. Before you type it in. Okay? Before you type it in, what kind of number do you expect to get? Before you get an answer, before you type it in, you expect what? What? A lower number than what? A number lower than what? A number lower than 250. You get 875. What's that tell you? You did it wrong. Does that make sense? Okay? If you get 800, something's wrong. Fix it. Okay? So we get 183 point. Okay. Questions there. Remember, real quick, and just I had this on here just so that it's here for the video. Growth, we have a b that's what? For growth, we have a b that's greater than 1. So examples of 2.7, 2.9, 3.8. These b values would all cause a growth of some sort. Decay.
It's less than 1.
Okay, has a b value that is less than 1, but still greater than 0. Okay, so it's between 0 and 1. Okay. So what examples of them? Give me examples of b values that would cause decay.
0.9.
0.9 would do it.
0.6.
0.6 will do it. Any others? Any other number will cause decay? Okay. 0.25. Okay. Or something like
0.50.
4 or 5. And 4 over 5 would cause a decay. 2 over 3 would cause a decay.
What about
Oh.
1/2?
1/2 would cause a decay. That would cause a decay. Can you think of a fraction that will cause a growth? Say again? 6 over 5 will cause a growth. 6 over 5 will cause a growth. Say again? 4 over 3 would cause a growth. Cool. Alright.